All right, let's dive in. Today, we're talking about something you've probably used, I don't know, a dozen times already today, but I bet you've never really seen it. I'm talking about the humble metal eyelet.
I mean, it's so true, right? You've got them on your shoes, your jackets, your bags. They're literally part of the invisible infrastructure of our daily lives. So, that's exactly the question we're going to dig into. What is the real story here? We are about to uncover the mind-blowing precision engineering, the ancient history, and the massive global industry hiding inside this tiny, tiny piece of hardware. Okay, section 1, a humble metal ring. Because, yeah, it's more than just a hole. First things first, let's talk about what these things are actually made of. And you might think, who cares? But it turns out the choice of metal isn't random at all. Nope, it is a critical engineering decision. And this slide just lays it out perfectly. The choice of metal basically defines the eyelet's entire destiny. You've got brass on one side. That's got that nice, corrosion-resistant kind of golden sheen you'd find on a luxury handbag. But what if that same eyelet is going on a boat sail? Well, then it has to be stainless steel. Has to be. Otherwise, the salt water would just eat it alive. See? The material has to match the mission. All right, so you've picked your metal. Now, how in the world do you turn a flat sheet of it into a perfect little ring? Well, that brings us to the manufacturing process. And let me tell you, it is way more complex than you might think. Honestly, it's like a multi-stage mechanical ballet. You've got these high-speed presses just punching out discs. Boom, boom, boom. Then those discs get drawn, basically pulled, into that familiar cup shape. The barrel gets trimmed, the edges are smoothed out, and then it's off for finishing. Every single step is perfectly calibrated, just flowing seamlessly into the next. And here's where it gets absolutely mind-boggling. The margin for error here is just 1/1000th of an inch. I mean, stop and think about that for a second. That is thinner than a human hair. If any single dimension is off by more than that, the whole thing just fails when you try to install it. It'll crack, it'll bend the wrong way, or it'll just fall right out. Incredible. So after all that insane mechanical precision, the eyelet goes on this complex chemical journey. First, it gets cleaned with acids. Then it's electroplated. That's where they use electrical currents to coat it with other metals, like nickel or gold for that finish. And for aluminum eyelets, they use a process called anodizing, which creates this super hard surface that you can dye literally any color you want. It's this beautiful fusion of mechanics and chemistry. Okay, section 3, the precision placement. So, you've made a perfect eyelet. Great, but that's only half the battle. Now you have to actually get it into the material, the fabric, the leather, whatever it is, and do it perfectly. Every single time. And believe me, that brings a whole new set of challenges. The secret weapon for installation is this tool called a die set. And it's basically a perfectly matched pair of metal tools. The bottom one holds the top of the eyelet, the flange, and then the top part comes down with this incredibly precise amount of force to roll the barrel outwards, clamping it right onto the fabric. The geometry of the die has to be a perfect, and I mean perfect match for the eyelet. And this right here just illustrates the crazy balancing act involved. It is all about the pressure. If you don't apply enough force, the eyelet's going to be loose, it might just fall out later, but if you apply too much, the metal barrel splits, or even worse, you tear the very fabric you were trying to reinforce. It's this tiny little engineering problem that has to be solved like hundreds of times a minute on an assembly line. Okay, let's zoom out a bit. We've seen how a single eyelet gets made and installed, right? But the bigger story here is about incredible scale, deep history, and a surprising amount of variety. This is what we're calling the billion-piece puzzle. And you'd be forgiven for thinking this is a modern invention, but it's not. Believe it or not, the basic idea goes back thousands of years. We're talking ancient Egypt, ancient Rome. Back then, artisans hammered every single ring by hand. It was the Industrial Revolution in the 19th century that just completely changed the game, turning this handcrafted item into a mass-produced component that would, well, change industries forever. And when I say mass-produced, that is a serious understatement. We are talking billions with a B. Billions of these things get made every single year. Just think about it for a sec. A single pair of boots might have, 20 eyelets? Now multiply that by all the shoes and all the tarps and all the clothes made across the entire planet, you start to get a sense of the just enormous scale we're dealing with. But here's the thing, not all eyelets are created equal, not by a long shot. They're governed by these really strict international standards. So the eyelet on your everyday sneaker, yeah, that just needs to be the right size. But the one on a military boot, oh, that gets tested for pull-out strength under what's called a mil spec, a military specification. And the one on a parachute harness? Well, that's a full-on aerospace-grade component, where flawless material integrity is literally a matter of life and death. And the eyelet family is just huge. You have your classic, plain old eyelet for shoes, sure. But then you get into things like two-piece grommets, which have a washer for extra strength on things like tarps, or, and this is my favorite, spur grommets. They have these little teeth, tiny metal teeth that literally bite into the fabric for an unbreakable grip. Every single one is a specialized tool designed for a very specific job. You know, the story isn't over either. Just like so many other industries, the next big challenge is sustainability. Remember all those chemical finishing processes we talked about? Well, there's a huge push now to replace them with greener alternatives and to use more recycled metals in the first place. The goal is simple: make this tiny, essential component as sustainable as it is strong. So really, the next time you're lacing up your shoes, just take a second. Look at that tiny metal ring. It's not just a hole, is it? It is a marvel of metallurgy, precision engineering, and global logistics, all packed into this tiny space. It's a small part with a truly massive story. And it just makes you wonder, what other everyday objects are hiding this much complexity right in front of our eyes?